So far, we have only selected columns from a single table. But in the real world, we quite often select columns from multiple tables. And that's what I'm going to show you over the next few tutorials. So on the left side, if you look at our orders table, let's select all the data here. In this table, we're using the customer ID column to identify the customer that has placed each order. Now, as I told you before, we don't store customers' information here, like their phone number, their email, their address, because this information can change in the future. And if a given customer has placed multiple orders, then we'll have to come back and change multiple records. We don't want to do that. That's why we have separate tables for customers and orders. Now, in this tutorial, I'm going to show you how to select the orders in the orders table, but instead of showing the customer ID, show the full name for each customer. So let's go back to our query window. All right, so we want to select everything from the orders table. Now we should combine the columns in this table with the columns in the customers table. That is where we use the join keyword. Now here we can optionally type inner join, because in SQL we have two types of join, inner join and outer join. We'll look at outer joins later in this section. So for now, we're only using an inner join, and this inner keyword is actually optional, so we don't have to type it. So we want to join the orders table with the customers table. Now, on what basis do we want to join these tables? Well, here in the customers table, we have this customer ID column. So if we put these two tables next to each other, we want to line up the records such that the customer IDs are equal. That is where we use the on phrase. So after on, we type out a condition. Here's the condition we need to type out. Orders.customer_ID should be equal to customers.customer ID. Now, this is getting outside of the screen, so let me break out this line. That's better. So with this query, we're telling MySQL that, hey, whenever you're joining the orders table with the customers table, make sure that the customer ID column in the orders table equals the customer ID column in the customers table. Now let's execute this query. Look at the result. Since we're selecting everything here, the first few columns are from the orders table because we have listed that first. Now, after all the columns in the orders table, we have the columns in the customer table. So customer ID, first name, last name, and so on. Now let's simplify the result set and select only order ID, first name, and last name. So back to our query, we select order ID, first name, and last name. Now let's execute the query. That is better. So next to each order ID, we can see the name of the customer that placed that order. Now, what if we want to display the customer ID here as well? Well, let's put that here and see what happens. Customer ID. Execute the query. We get an error. So if you look at the output window, down the bottom, you should see an error saying column customer ID in the field list is ambiguous. Now, unfortunately, I cannot show you this error because the size of my recording window is smaller than MySQL workbench. But that aside, let me explain why we're getting this error. Because we have this customer ID column in both the orders and customers tables. So MySQL is not sure which table do we want to select this column from. That is why it's saying this column is ambiguous. So we need to qualify this column by prefixing it with a table name. We can either pick it from the orders table or the customers table. It doesn't really matter because the values are equal, right? So in situations where you have the same column in multiple tables, you need to qualify them by prefixing them with the name of their table, okay? Now let's execute the query one more time. So there you go. We have order ID, customer ID, and the full name. Beautiful. Now, one more thing before we finish this tutorial. If you pay close attention, we have repeated the word orders in multiple places. We have it here, as well as in the join condition. The same is true about the customers table. We have repeated that here. We can get rid of this repetition and make our code simpler by using an alias. So right after each table, we can give it an alias, O as in short for orders. So by convention, we abbreviate the table's name. Now, wherever we have orders, we should replace that with O. So here in the join condition, we replace orders with O, and also one more time, in the select clause. There you go. We can also apply an alias for the customer's table. We call it C, and then we simplify our join condition like this. So this is how we can join columns from multiple tables. Now, for your exercise, I want you to look at the order items table. So in this table, we have these columns: order ID, product ID, quantity, and unit price. Now, I want you to write a query and join this table with the products table. So for each order, return both the product ID as well as its name, followed by the quantity and the unit price from the order items table. And by the way, make sure to use an alias to simplify your code. All right, first, let's select everything from the order items table and then join it with the products table. How are we going to join these tables? On order underline items dot, well, actually, let's just give this an alias right away. So we use OI as an abbreviation for order items and P as in short for products. So OI dot product ID should be equal to P or products dot product ID. And by the way, remember that when you give an alias to a table, you have to use that alias everywhere else. So here I cannot type out products. MySQL is going to yell at me. So let's use the abbreviation. All right, this is how we join these tables. Let's execute this query up to this point. All right, so we see all the items from the order items table, followed by the columns from the products table. Now, we want to explicitly select a few columns here. So from the order items table, we want to select order underline ID. Well, technically, we don't have to prefix this with the table name because this column is not repeated in multiple places. So it's not ambiguous. So let's make the code shorter. That's better. Now we want to select the product ID column. But because this column exists in both tables, we have to prefix it with a table name, either OI or P. It doesn't really matter. Next, we want to select quantity and finally unit price. Now, actually here we have this unit price column in both tables. So this is the unit price in order items table, and this is the unit price in the products table. Now, you might be curious why we have this column in two places. The reason for this is that the price of products can change. So for each order item, we want to have the price at the time the user or the customer placed the order. So this is a snapshot of the price at a given point in time. The unit price that we have in the products table is the current price right now. This is very important for reporting, otherwise we cannot calculate the sales properly. So because we have the unit price column in two places, in this case, we should pick it from the order items table because this is the price at the time of placing the order. Now let's execute the query. So here's the final result. In the real world, when you work as a developer or a database administrator, quite often you will have to work with multiple databases. In this tutorial, I'm going to show you how to combine columns from tables across multiple databases. That's pretty easy. So in the SQL Store database, we have these tables that you're fairly familiar with. Now imagine this products table was not here. Now, if you look at the SQL inventory database, you can see here we have another products table. This products table is exactly the same as the products table that we have in the SQL Store database. So it has the same columns and the same data. Now, technically, this is not a good design. You don't want to have the same table repeated in multiple places. But for this demo, let's just imagine that we don't have the products table here. So we want to join the order items table with the products table in the SQL inventory database. Let's get started. So select everything from the order items table. Let's give it an alias straight away. We want to join this with the products table. This products table is part of the SQL inventory database. So we'll have to prefix this with the name of its database. So we type out SQL inventory dot. Now, once again, we can give this an alias like P, then type out our join condition. So OI dot product ID should be the same as P dot product ID. Let's run the query. There you go. So we successfully joined tables across multiple databases. Now, note that we're prefixing the products table with the name of its database because the current database that we're writing this query against is the SQL Store database. Take a look. In the Navigator panel, the SQL Store database is displayed in bold because earlier we wrote the use statement to select a database. That was SQL Store. Now, what if we select the SQL Inventory database? Let's see what happens. So, SQL Inventory. Now, because we have multiple statements, we have to terminate this with a semicolon. Now, we want to select everything from the order items table, but we don't have this table inside of this database. So now we'll have to prefix this table with the name of its database. That is SQL_store. Let's execute the query. Okay, everything works beautifully. So here's the lesson. You only have to prefix the tables that are not part of the current database. In other words, your query will be different depending on the current database. In SQL, we can also join a table with itself. Let me show you an example. Take a look at this database, SQL HR. In this database, we have these two tables, employees and offices. Let's take a look at the data in the employees table. There you go. So here we have these columns, employee ID, first name, last name, their job title, salary, and reports to. This is the ID of the manager for this person or this employee. Now, once again, we don't want to repeat the manager's information here, like their phone number, their address, because this information can change in the future. So we're only using their identifier or their ID to refer to them in this table. Now, where can we find the information about this manager? Well, this manager is actually an employee of the same organization. So look at this example. The manager ID is 37270. Now, if you look on the left side, here's the ID of that manager, which is another employee. Now, who's the manager for this employee? Let's take a look. We don't have any values here, so the value for this cell is null. So this employee doesn't have a manager, and that means they are the CEO. So now let's go ahead and write a query to join this table with itself so we can select the name of each employee and their manager. Back to our query window, first we need to select the SQL HR database. Next, we select everything from the employees table. We give it an alias like E. Now we need to join this table with itself. So once again, we type out employees, but we need a different alias. What should we call this alias? Well, we want to join this table with itself so we can find the managers, right? So we can use M as in short for managers. Now let's type out our join condition. So from the employees table, we need to join the reports underline 2 column to the managers table, which is basically the employees table itself. And what column? That is employee underline ID. Now let's execute this query and see what we get. So we see all the columns from the employees table repeated. The first set of columns represent information about the employees. And then after that, we have information about the manager. In this case, we have only one manager in this table. But with this technique, we can easily create an organization chart. We can have a hierarchy of managers. Now let's simplify our query and select only the name of the employee and their manager. So back here, since every column in the employees table is repeated twice, we need to prefix each column with a table name. For example, from the employees table, you want to get employee ID as well as the first name. And then from the managers table, you want to select the first name as well. So every column should be prefixed with the table name, or more accurately, the alias, because all these columns exist in 2 tables, right? Let's go ahead and execute this query. So this is what we get, employee ID, first name, and here's the manager's first name. We can improve this query by giving an alias to this column, because it doesn't make sense to have 2 first name columns. So let's give an alias to the third column, manager. Now let's execute it one more time. And here's the end result. So we have the employee ID, first name, and manager. So joining a table with itself is pretty much the same as joining a table with another table. The only difference is that we have to use different aliases and we have to prefix each column with an alias. This is what we call a self-join. Next, I'm going to show you how to join more than 2 tables. In this tutorial, I'm going to show you how to join more than 2 tables when writing a query. For example, back to our SQL Store database, look at the orders table. Now you know how to write a query to join this table with the customers table to return information about the customer who placed each order. But here we also have another column, status, which is similar to the customer ID column. So the name of the statuses are not stored in this table. They're somewhere else in the order statuses table. Let's have a quick look here. So our orders can be either processed, shipped, or delivered. And these are the identifiers for each of these statuses. Now back to our orders table, in the status column, we store the order status ID. So now we should write a query to join the orders table with 2 tables, the customers table and order statuses table. The result of this query is going to look like this. So for each order, we see the order ID, the date, the first and last name of the customer, and finally the status of the order. This is a beautiful report we can create for our users. So let me show you how to write this query. Back to our query editor, first we need to select the SQL Store database. Now we need to select everything from the orders table. Let's give it an alias. Next, we need to join this with the customers table. On o.customer ID should be equal to c.customer ID. Nothing new so far, exactly like before. Now here we can write another join keyword to join the orders table with order statuses table. So we type out order statuses and also we give it an alias like OS. What is our join condition? Well, back in the orders table, here we have this status column. So the value in this column should be equal to the order status ID column in order statuses table, right? So back to the query. So orders table dot status should be equal to order statuses dot order status ID. Make sure to get the name right. Don't have a typo. Otherwise, you're going to get an error. So this is how we can join 3 tables. Now, in the real world, as you work on more complex problems, you may end up joining even 10 tables. So this is not uncommon in the SQL world. Now let's go ahead and execute this query. First, we get the columns from the orders table, followed by the columns from the customers table, and so on. This result is so complex and hard to extract information from. So let's explicitly select a few columns here. From the orders table, we want to select the order ID column, as well as the order date. Then from the customers table, we want to select the first name and the last name. And finally, from the order statuses table, we want to select the name column. Now we can give this an alias like status. That's better. Let's execute the query one more time. So here's the end result. We have order ID, order date, the name of the customer, followed by the status of the order. All right, for your exercise, take a look at this SQL invoicing database. Here we have this table, payments, and these are the payments that each client has made towards a given invoice. Let's take a look at the data. So we have these columns, like client ID, that identifies the client. So we can join this table with the client's table to see the name of the clients. Next, we have invoice ID. We also have date, amount, and payment method. So similarly, we can join this table with the payment methods table here. Let's have a look at the data in this table. These are the payment methods: credit card, cash, PayPal, and wire transfer. So back to the payments table, I want you to write a query and join this table with the payment methods table as well as the clients table. Produce a report that shows the payments with more details, such as the name of the client and the payment method. All right, first we need to use the SQL invoicing database. Now we can select everything from the payments table, which we call P. Next, we need to join this with the client table, which we call C. On P.clientID should be equal to C.clientID. Let me double check the column name to make sure I got it right. So back to the payments table, the column is called client ID. We also have a column called payment method that we should join to the payment method ID column of the payment methods table. So back to the query. Once again, we use a join statement here, join with payment methods. We give it an alias PM on p.payment underline method should be equal to pm.payment method ID. Make sure to type it out correctly, otherwise you're going to get an error. So let's go ahead and execute the query up to this point. There you go. Finally, let's handpick the columns that make the most sense. So from the payments table, let's select the date, followed by invoice ID. What else do we have here? So we have client ID, invoice ID, date, amount, and payment method. I'm going to pick the amount column from here as well. So back to the query, p.amount. Now we need to add information about the client. Let's take a look at this table, clients. So here we have columns like name, address, city, and so on. All we need here is the name column. So back to the query. From the clients table, let's select the name column. And finally, from the payment method table, let's select, what is that column called? It's called name. So back to the query, pm.name. So here's the end result. Now we can put these columns in any order that we want. It doesn't really matter. Let's execute the query and make sure everything works. So on this date, for this invoice, we have a payment for this amount by this client using a credit card. In all the examples you have seen so far, we use a single column to uniquely identify the rows in a given table. For example, in the customers table, we have this customer ID column, which uniquely identifies the rows in this table. But there are times that we cannot use a single column to uniquely identify records in a given table. For example, look at the order items table. In this table, we have columns like order ID, product ID, and so on. Now, if you look at the data, you can see that the values in the order ID column are repeated. They're duplicated. We have 222, 66, and so on. So we cannot use this column on its own to uniquely identify each record. The same is true for the product ID. The values in this column are also duplicated. So in this table, we use the combination of the values in both these columns to uniquely identify each order item. As an example, in this order, we have 3 items for products 1, 4, and 6. And for each product, we have the quantity and unit price. So if we use the combination of the values in both these columns, we can uniquely identify each order item. In other words, we don't have 2 records for order ID 2 and product ID 1. We only have a single record for that item, right? Now let's open this table in the design mode. So over here, click on this middle icon that looks like a tool. Note that this yellow key that represents the primary key exists on both these columns. This is what we call a composite primary key. A composite primary key contains more than one column. Now, why does this matter? Well, when you have a table with a composite primary key, you need to learn how to join that table with other tables. For example, here we have this table order item notes that we use to keep notes for each order item. Let's take a look at the data here. So we have this column note ID, which uniquely identifies the records in this table. Next to that, we have order ID and product ID. You learn that the combination of these 2 columns uniquely represent an order item. So here for order number 2, for product number 1, we have 2 notes. Now let me show you how to join this table with the order items table. So back to our query. You can see that I have already selected the SQL Store database, so I'm not going to type out a use statement. All right, let's select everything from the order items table, give it an alias. Now we need to join this with order item notes. Also, we give it an alias. How are we going to join these tables? Based on 2 columns. Back to the order items table. These are the columns that we need to use in our join condition. So in the order items table, we have this order ID column. This should be equal to the same column in order item nodes table. So OIN dot order ID. But this is not enough. We should also join these tables based on the product ID column. So we type out and then we type out our second condition. So order items dot product ID should be equal to order item nodes dot product ID. This is what we call a compound join condition. So we have multiple conditions to join these two tables. In this tutorial, I'm going to talk about the implicit join syntax in MySQL. So here we have a basic inner join. We're selecting everything from the orders table, joining it with customers table on orders.customer ID equal to customers.customer ID. Pretty basic. There is another way to write this query using implicit join syntax. Let me show you how that works. So we select everything from. Now here we can type out multiple table names. So orders, comma, customers. And we can also give them an alias. So C and O. And then we move this join condition to the where clause. So I'm going to copy this from here, type out a where clause, and paste the condition. These two queries are equivalent. What we have here is called implicit join syntax. Now, even though MySQL supports this syntax, it's something that I suggest you not to use, because if you accidentally forget to type out the where clause, you will get a cross join. Let me show you what I mean. So first, I'm going to delete the first query and execute this. So we get 10 records because we have 10 orders in this database. So far, so good. But what happens if we accidentally forget to type out the where clause? Instead of 10 records, we're going to get probably 100 records, because every record in the order table is now joined with every record in the customers table. This is what we call a cross join. Now, later in this section, I'm going to talk about cross joins in more detail. But what I want to point out in this tutorial is that it's better to use the explicit join syntax. So we use join because this syntax forces you to type out the join condition. If you simply join orders with customers without typing the join condition, you're going to get a syntax error. So to recap, be aware of the implicit join syntax, but write all your joins using the explicit syntax. Earlier in this section, I told you that in SQL, we have two types of joins, inner joins and outer joins. Now, so far, you have only seen examples of inner joins. And I also told you that this inner keyword is optional. So whenever you type out a join, you're using an inner join. In this tutorial, we're going to look at outer joins and the problems they solve. So let's start by writing a query that uses an inner join, and then we'll convert that inner join to an outer join. So select everything from the customers table, join it with the orders table on c.customer ID should be equal to o.customer ID. Pretty basic, right? Now for clarity, let's pick a few columns from these two tables. So from the customers table, I want to pick customer ID and first name. And from the orders table, I want to pick order ID. Now finally, let's sort the result so we can clearly see what we get. So order by c.customer ID. Let's execute this query and see what we get. So here's the result. For customer number 2, called Ines or Ines, whatever, we have two orders, order 4 and order 7. Similarly, for customer number 5, we have two orders and so on. Now there's something missing in this result. We only see customers who have an order in our system. These are customers 2, 5, 6, 7, 8, and 10. But if you look at the customers table, you can see that we have other customers like customer number 1, customer number 3, and so on. Now currently, we don't have any orders for these customers, and that's the reason we don't see them in this result set. But what if you want to see all the customers, whether they have an order or not? That's when we use an outer join. Let me show you how that works. So back to our query. The reason we only saw customers who have an order was because of this join condition. When joining these two tables, we are only returning records that match this condition. So for a given customer, if we do have an order, that record is returned. But as you saw a second ago, some of our customers don't have an order. So for those customers, this condition is not valid, and that is the reason they're not returned in the result set. To solve this problem, we use an outer join. Now in SQL, we have two types of outer joins. We have left joins and right joins. When we use a left join, all the records from the left table, in this case customers, are returned whether this condition is true or not. So we get all the customers, and if they do have an order, we'll see the order ID as well. Let's execute this query and see what we get. So there you go. Customer number 1 doesn't have an order, and that's why we get null in this cell. Customer number 2 has 2 orders, 4 and 7. Customer number 3 also doesn't have an order, so we have null for order ID. This is the result of a left join. So back to our query, when we use a left join, all the records from the left table are returned whether this condition is true or not. Now, what if we use a right join? In this case, all the records from the orders table are returned whether this condition is true or not. Let's execute this query and see what we get. So we get the same result as before when we use an inner join, because we're selecting all the records from the right table, which is the orders table. So we don't see all the customers, we see all the orders, right? Now, if you want to use a right join and still see all the customers, you need to swap the order of these tables. So we put the orders table first. That's going to be our left table. And then we put the customers on the right side. So now with this query, we'll return all the records from the right table, which is the customers table. When we execute this, we get all the customers, whether they have an order or not. Beautiful. Now, one last thing before we finish this tutorial. I've seen developers use the outer keyword here, so either right outer join or left outer join. But technically, the outer keyword is optional, just like the inner keyword, so you don't have to type it out. So I'm going to remove this to make my code shorter and easier to understand. So to recap, if you use the join keyword, you're doing an inner join. And if you do a left or right join, you're doing an outer join. Here's your exercise for this tutorial. I want you to write a query that produces this result. So we have 3 columns here: product ID, name, and quantity that I picked from the order items table. So here we need to join the products table with order items table, so we can see how many times each product is ordered. However, if we do an inner join, we'll only see the products that have been ordered. But here I'm doing an outer join, so product number 7 has never been ordered, but it still exists in the result. We see null for the quantity. So go ahead and write an outer join to produce this result. All right, first we select everything from the products table and then do a left join with the order items table. Our join condition is p.productID equals oi.productID. So because we're using a left join, we'll get all the products in the products table, whether this condition is true or not. If they have never been ordered, we'll still see them in the result. Now, let's pick a few columns for clarity. So p.productID, p.name, and oi.quantity. That's it. Let's execute the query. We get the same result as before. So all the products are here, and product number 7 has never been ordered, so we see null for the quantity. Similar to inner joins, we can use outer joins between multiple tables. Let me show you. So here's the query that we wrote in the last tutorial. We're doing a left join between customers and orders tables. So when we execute this query, we get all the customers, whether they have an order or not. If they have an order, we see the order ID. Beautiful. Now, if you look at the orders table, you can see that some of our orders have a shipper ID. These are the orders that have been shipped. So now let's join the orders table with the shippers table to display the name of the shipper in the result. So back to our query. After this left join, let's write another join. Here I'm doing an inner join. So let's inner join the orders table with the shippers table. Join shippers. We call it sh. On, what is the join condition? Well, o.shipper ID should be equal to sh.shipper ID. All right. So in this query, we have a left outer join and an inner join. Let's see what we get. All right. We only see 5 records, but we have more orders. So here we have the same problem we had before. Some of our orders don't have a shipper, and that is why they are not returned here. In other words, this join condition is not true for some of our orders. So back to the orders table. As an example, this first order doesn't have a shipper. Shipper ID is null, and that is why it's not returned in the query result. So to solve this problem, we should use a left join. We want to make sure that all orders are returned, whether they have a shipper or not. So back to the query, we need to replace this inner join with the left join. So let's execute the query and see what happens. Now we should have quite a few more orders. There you go. Now to make this example more interesting, I'm going to add the shipper name here. So back to our select clause. Let's add a new column. So shipper.name. And we can give it an alias like shipper. Let's execute the query, and here's the result. So we get all the customers, whether they have an order or not. And for those who do have an order, we get all the orders, whether they have a shipper or not. This is the power of outer joins. Now, in the last tutorial, you learned that you can get the same result with both a left join or a right join. You just have to swap the order of the tables. However, as a best practice, avoid using right joins, because when you're joining multiple tables and you have left and right and inner join, things get really complex. Someone else reading your code will have difficulty visualizing how you're joining these tables. As an example, if you had a right join here and then a left join after, it would be harder to visualize how these tables are getting joined. So as a best practice, avoid right joins and use left joins instead. And here's your exercise for this tutorial. I want you to write a query that produces this result. So here we have these columns: order date, order ID, the first name of the customer, the shipper, and you can see that some of our orders are not shipped yet, so here we have null. And finally, the status. So go ahead, spend 2 to 3 minutes on this exercise. When you're done, come back, continue watching. All right, let's select everything from the orders table. Now we should join this with customers. On o.customer ID should be equal to c.customer ID. Here I'm using an inner join because every order does have a customer. So this condition is always valid. It doesn't matter if we use a left join or an inner join here, okay? Now, before going any further, let's pick our columns. So from the orders table, I want to pick order ID, followed by order date, and then customer.first name, which we can optionally rename to customer. All right. Next, we need to select the shipper. So we join the result with the shippers table on order.shipper ID equal to shipper.shipper ID. However, if we use an inner join here, because some of our orders don't have a shipper, we're only going to see the orders that have been shipped. Let me show you. So for clarity, I'm going to add the shipper's name here. So shipper.name as shipper. Let's execute the query. There you go. We only see the orders that have been shipped, but we want to see all the orders, right? So we need to change the second join to a left join. So all orders are returned whether they have a shipper or not. Let's execute the query one more time. There you go. Now we see all the orders from number 1 to number 10. Beautiful. Finally, we need to add the status column here. So we need to do another join here. Join with order statuses, which we abbreviate as OS, on o.status equal to os.order status ID. You can see that I have designed this database such that sometimes our column names are exactly identical, but in other cases, they don't match. So in the order table, we call this column status as opposed to order status ID. And this is deliberate because a lot of real databases are like that. All right, now let's add the status name here. So order status the name as status. Execute the query, and we can see all the orders here. For each order, we have the date, the customer, the shipper, and the status. Earlier, we talked about self-joins in SQL. So here in the SQL HR database, we have this employees table. We wrote a query to get all the employees and their manager. So here we have this column, reports to, that specifies the manager for each employee. So let's go back and rewrite this query to get all the employees and their manager. Back to our query editor window. First, let's use the SQL HR database. Then select everything from the employees table. We give it an alias and then join it with itself. So this is what we call a self-join. Now we're going to use a different alias like M for managers. Now, what is the join condition? E.reports2 should be equal to M.employee ID, right? Now for clarity, let's pick only 3 columns. So E.employee ID, E.firstname, and M.firstname, which we'll rename to manager. All right, let's execute this query and see what we get. So here's the result. As we can see, all these employees have the same manager. However, there's something missing here. We don't have a record for this person, this manager himself. So what is missing is a record where we can see the employee ID for this person, their name, and their manager, which should be null because this person is the CEO or the head of the company. But why is this happening? The reason is our inner join. Because this condition we have here will only return people who have a manager. We can solve this problem by using a left join. So we do a left join because we want to get every employee in this table, whether they have a manager or not. Okay, now let's execute the query one more time. There you go. Now we have a record for this person, the manager. As you can see, this person does not have a manager. That's why we have null here. Back to our SQL Store database. Here we have a simple query that joins the orders table with the customers table. And here's our join condition. You have seen several examples of this before. Now, as our queries get more complex, these join conditions get in the way. They make our queries hard to read. But the good news is that in MySQL, we have a powerful feature for simplifying these queries. If the column name is exactly the same across these 2 tables, we can replace the on clause with the using clause, which is simpler and shorter. Let me show you. So I'm going to comment out this line and instead type out using. In parentheses, we type out the column name, that is customer ID. What we have on line 7 is exactly identical to what we have on line 6, but it's shorter and easier to read. So let me delete this line. We can add another join statement here to join the orders with the shippers. So join with shippers using shipper ID. In both these tables, we have a column with the exact same name. All right, now let's execute this query. This is what we get. We have the order ID followed by the first name of the customer. Let's add a new column here. So I'm going to add sh.name. That is the name of the shipper. So shipper. Now, obviously, because some of our orders are not shipped, we need to replace this inner join with a left join. So we can use the using keyword with both inner and outer joins. Let's execute the query one more time. There you go. Now we have the name of the shipper next to each order. Beautiful. However, we cannot use this technique to join the result with the order statuses table. Because in the orders table, we have this column called status, but in order statuses table, this column has a different name. It's order status ID. Let me show you. So order statuses, columns, there you go, order status ID. So the using keyword only works if the column name is exactly the same across different tables. Now, what if we have multiple columns in our join condition? For example, earlier we talked about this order items table. I told you that in this table, we have a composite primary key, which basically means a primary key that consists of multiple columns. So the combination of these two columns uniquely identify each record in this table. Now, if you want to join this table with order item notes table, in our join condition, we should compare both these columns with their corresponding columns in the order item notes table. So let's quickly write that query and then simplify it with the using keyword. So select everything from order items. Now join it with order item notes on. So here we need to compare oi.order ID with oin.order ID and oi.product ID equal to oin.product ID. This join condition is kind of messy. It's hard to read this query. Now we can simplify this query with the using keyword. So we type out using. In parentheses, we add both columns and separate them using a comma. So order ID and product ID. Isn't that better? Now for exercise, back to our SQL invoicing database, write a query to select the payments from the payments table and produce something like this. So in this table, we have the date, the client, the amount, and the payment method. We can see on what date who has paid how much using what payment method. All right, I'm going to use the SQL invoicing database and then select everything from the payments table, join it with the clients table using client ID, because in both these tables, we have the client ID column. Next, we need to join this with payment methods. However, the column name between these two tables is different. So in the payments table, we have a column called payment method, but in payment methods table, our column is called payment method ID. So here we cannot use the using keyword, and we'll have to use the on clause. So on p.payment underline method equals pm.payment method ID. Now let's pick our columns. So payment.date, client.name, and we rename this as client. Next, we pick the amount, and finally the payment method. So let's rename that to payment underline method and execute the query. There you go. This is what we get: the date, the client, the amount, and the payment method. In MySQL, we also have another simpler way to join two tables. It's called a natural join, and it's easier to code, but it's not something that I recommend because sometimes it produces unexpected results. But let me quickly show you how it works in case you see it somewhere, so at least you're familiar with it. So back to the previous example, let's select everything from the orders table. Now we should do a natural join with the customers table. Now with these natural joins, we don't explicitly specify the column names. So the database engine will look at these two tables and it will join them based on the common columns, the columns that have the same name. And that is the reason this query is shorter to write. So for clarity, let's pick a couple of columns here: o.order ID and c. Let's say first name. Let's execute the query. There you go. So we see all the orders and the customers who placed them. So natural joins are really easy to code, but they can be a little bit dangerous because we're letting the database engine figure out or guess the join. We don't have control over it. For this very reason, natural joins can produce unexpected results, and that's why I discourage you to use them. In this tutorial, we're going to look at cross joins in SQL. We use cross joins to combine or join every record from the first table with every record in the second table. Here's an example. Let's select everything from the customers table. Now here we do a cross join with the products table. So every record in the customers table will be combined with every record in the products table. And that is why we don't have a condition here. Okay, so this is what we call a cross join. Now for clarity, let's pick a couple of columns like c.first name. We rename it as customer, and then product.name, which we rename to product. Also, Let's sort the result by customer.firstname. Now let's execute the query. Here's the result of a cross join. So first we have Amber as the customer, and here are all the combinations of Amber with different products. Next we have Barbara or whatever it is, and again we have the combination of this customer with all the products. Now in this particular example, it doesn't really make sense to use a cross join. A real example for using cross joins is where you have a table of sizes like small, medium, large, and a table of colors like red, blue, green, whatever. And then you want to combine all the sizes with all the colors. That is when you use a cross join. Now what we have here is called the explicit syntax for a cross join. We also have the implicit syntax, which looks like this. Instead of typing out the cross join, we type out multiple tables in the from clause. So customers and orders. Both these queries produce the same result. But I personally prefer to use the explicit syntax because it's more clear. And here's a simple exercise for you. Do a cross join between shippers and products. First do it using the implicit syntax and then using the explicit syntax. It's pretty straightforward. I just want you to get your hands dirty in the code and get used to this syntax. All right, first I'm going to use the implicit syntax, and then I'll show you the explicit syntax. So let's start by selecting everything from two tables, shippers and products. Now for clarity, let's pick two columns, shipper.name, which we rename to shipper, and product.name, which we rename to product. And finally, let's order everything by shipper.name. Let's execute the query. This is what we get. So the combination of all shippers and all products. Beautiful. Now let's use the explicit syntax. So we select everything from the base table, in this case shippers, and then do a cross join with products. That produces exactly the same result.